Chapter 17, Video Reassessment, problem 28 from the textbook. Basically what we're going to be doing here for the first part, for part A, it is asking us to find the electric fields of point A and point B due to point charges, the positive 4.2 nanocoulombs and negative 6.4 nanocoulombs. Now, to start this off, we use this little equation right here, which you taught us, but I can't remember the name of for the life of me. But that's how we find our electric fields. So K is equal to 9 times 10 to the 9th. Q is whatever our charge is for the whatever point we're looking at, which for the first part of A is 4.2 times 10 to the negative 9 nanocoulombs, and our R, which is the distance from the point that we're trying to find to the point charge right here. Now take all these three numbers and throw them into this little equation right here, and that gives us 630 volts, which is the potential, which is the electric potential at A due to the positive charge. And after that, do the exact same thing again, just with the different numbers. So now we're looking at the other point charge and how it relates to this. So at A, due to negative 6.4 to nanocoulombs and 15.9 centimeters. So take that, and that gives us negative 362 volts was the electric potential at A due to the negative charge. And to find our total, our net electric potential, simply take those two numbers and add them together, which since this was a negative, just becomes a minus sign, and that gives us 268 volts, which is our total electric potential for A. After that, we do the exact same thing for B, so that's why I just decided to exclude it for time's sake. And that gave us 165 volts, which is the total electric potential. Now to find the difference, the delta V, difference in electric potential from A to B, we use this little equation. We simply take delta, our electric potential at B and subtract it from our electric potential at A, and that gives us negative 165 minus 268, which gives us negative 443 volts. And that is the difference in electric potentials from here to here. Now, in order to find the work that is actually needed to make that trip, but with a point charge of positive 150, 1.5 nanocoulombs, not 150. That is in the middle here, so basically take this, change this number to 1.5. In order to find the work that has to be done by an outside force to make that trip, we have to use this little workforce electric potential equation is what it really is, but I think this is what you call the workforce equation. So this one's pretty simple. All we got to do is take our delta V, our change of potential, and then multiply it by the point charge, and that gives us negative 6.5 times 10 to the negative 7th joules. So in other words, you probably wouldn't really need all that much work to actually be done, since this is negative right here. It would probably just something that would happen on its own, really. So that's about it.